All right, so we've dealt with the first six, starting with power function, and then we did constant function, quadratic, linear, cubic, and square root, because square root like to dab. And so with that, we're going to go ahead and move on to the last five. And the last five start off with the absolute value graph. And hopefully everybody understands and remembers that one. Absolute value function. And that one is f of x, and it equals x with absolute value bars on it. Those are not ones, those are absolute value bars. So let's make them a little bit longer than ones would be. So absolute value bars. All right, now with that, again, hopefully everybody remembers what it looks like. And this looks like a letter. So we gotta remember what letter it is. So we already talked about the U. And then there was another letter that the cubic function kind of looked like an S type thing. But the other one was the V. V. Viva Victory. Viva Victory. All right, so we have a V. And again, they should match up. They should actually go the same length and everything. Yeah, my bad. All right, so with this, and it should come through the origin 0, 0. That didn't come through the origin correctly. So it should come to the origin 0, 0. Alright, so now we're going from, again, for domain, from left to right. Again, we have arrows on the left, arrows on the right. So that means here, from left to right, the domain is from negative infinity to positive infinity. So negative infinity to positive infinity. If we look at the range, going from bottom to the top, again, it starts at 0. So it starts at 0. And again, that's a closed circle. And then it goes up forever and ever and ever and ever and ever and ever and ever to those arrows. This means it's going up to positive infinity forever and ever and ever. To infinity and beyond. Alright, so we have that. Absolute value. Not bad. That's your V. Your V. Your V. Your V. Alright, so yeah, with that one. Now these next two, we're going to spend a lot of time with these, hopefully this whole semester. It's a kind of a big chunk of the semester. Is your exponential and logarithmic functions. So here we're going to talk about an exponential function first. And with an exponential function, you can see it one of two ways. You can see it looking like e to the x power, or we could be f of x is a to the x power. And a is just a number. Any number. Could be a positive number, could be a negative number, but it's a number. So a is a number. Alright, so with this one, this graph, it's important that you list and have all the stuff that's here. So here, if we look at it, this graph is going to come close and close to the x-axis, but will not touch it. And then it comes up and goes above, and the arrow here. It's an arrow down here on this side too. But if you look at it, the graph, it never touches the x-axis there. It gets closer and closer to the x-axis, but never touches it. Now, another thing that you're going to need to make sure you have is a thing called an asymptote. And we're going to talk about this more. And on this one here, we're going to draw a dotted line right here on the x-axis. A dotted line. That's considered our asymptote. And we'll talk more about that when we get into the lessons about exponential functions and all that good stuff. But it's important that you not only have the actual graph there, but you also have the asymptote with it too. Because if the asymptote's not there, that means the graph is wrong. It's important. Alright, so with this, because the graph gets closer and closer and closer, well, sorry, that's range. I'm talking about range. So let's talk about domain first. Going from left to right. So again, on this left side, we have an arrow. On the right side, we have an arrow. So since we have arrows on both sides, again, from left to right, we have negative infinity, positive infinity. From left to right, left to right. Okay, now for the range, that's a little bit different. So here we're going to go from the bottom, going to the top again. But here, this graph comes closer and closer and closer and closer, closer to the x-axis, but never really touches it. But with us, what we're going to need to say is we're going to make it equal to 0 there. Well, we say it gets to 0. But with it, if you look at it, it never touches the x-axis, which means there's never a closed circle on the x-axis at all. Never. So since there's not a closed circle on the x-axis at all, we're going to put a parenthesis right here. Because again, we know parenthesis means it is not equal to, is either greater than or less than, but not equal to. And so here it's going to be greater than 0, but we can't just say start at 1 because that means all the numbers, they say like 1 is like right here. That means all the other numbers here are going to be below 1. That's going to be like 0.5 and 0.002 and 0.111111 type thing. And if you just put 1 there, that means you skip all these numbers right there. So make sure that you put from 0 and then an arrow going, so from here going up. From 0, and we're going up forever and ever and ever because there's another arrow right there. Bam. So it goes to infinity. So we're going to say it has an open circle here at 0, but it's going to go all the way to positive infinity. So we're good. All right, now the log function does very similar to that. Logarithmic function. And again, we're going to talk more about this also. The logarithmic function has the word log in the function. Logarithmic. Come on. Should be simple. All right, so we can see the log function looks like this. We have the log function also that looks like this. And we'll get more in depth again once we go into these lessons about it. And the b is below the log. The log and the x are on the same line. B is below the line. All right, so for the log function, the graph looks like this. And with the log function, we have an asymptote here. Asymptote. But it's on now the y-axis instead of the x-axis. And so the graph gets closer and closer and closer to the x-axis, the y-axis, but it never touches the y-axis. It crosses the x-axis, but it never gets close. It never touches the y-axis. This gets closer and closer to it. So if you look at it and think about it, it's actually the flip of what we did right here for domain and range. So if you look at our domain here, go from left to right, it doesn't start at 0 exactly. It's like that whatever that next number after 0 is, like that 0.0000 something. So our domain, we're going to do another parenthesis. We'll start with 0. I'm going to go to positive infinity because we have an arrow on that side right there. And then the range goes on forever. So from negative infinity to positive infinity because there's an arrow here and an arrow up top. So it's flipped. And one thing we're going to learn about log functions and exponential functions is that they're inverses of each other. So if you flip one on top of the other, they're the exact same function. So they're inverses. They just flip the x and the y values. We'll talk about that later. That's a later thing. All right. So the last two is something that are the two functions that we're going to talk about at the very, well, no, not the very end, but closer to the end of this semester. And these ones, I want to make sure that you have at least seen them ahead of time to at least know what they look like, kind of, sort of, and then go from there. All right. So this one is considered our sine function. Our sine function. And here, and when we talk about this, we do sin x for the actual function notation. That is not sin, because we do not sin in this classroom. It is sine. Sine. Not sin, but sine. Because that's sine, that's sine. All right, now the next parts, here I'm going to throw these in, is 1 and 1 here, negative 1 and 1. And this next part here, I'm really not going to probably quiz you as much on this until we get to the actual part there, but I want you at least have seen this part and then go from there. So with our sine function, we're going to start here at 0, 0. It's going to go up, then back down, then below, and then back up again. So it looks kind of weird, but yeah, it's going to be okay. And then again here, it follows the same pattern that's going So it means it's going to go down here, back up, above at 1, and then back at 0 again. And here, we're going to connect them and we're going to make them curve graphs. So if you put them as sharp, like absolute value graphs, they're going to be wrong, because that's not what this function is. This function is not an absolute value graph. This is a sine function. And it's smooth, just like your cubic. All your curves and all your edges, all your perfect imperfections. So again, this is our sine and sine function. I'm going to throw these in. And we're going to talk about this more in depth once we get to the trig part of our class. But I just want to throw this at you now. So you can never say, I never saw this before. Alright, so again, for our domain and range here, it goes from, it has an arrow on both sides. So we have negative infinity to positive infinity. And for our range, it goes from -1 to 1, and they're all closed circles. So it's -1 is a closed circle, at +1 is a closed circle. So we have brackets. Right, and then our last function is our cosine function. And this is f of x equals cosine x. Not cos, but cosine. Not sin, but sine. Not cos, but cosine. Now, later on, I'll take points off your grade if you start saying the wrong thing, because you're sinning. Or you're cossing. We don't cos. Almost like cussing. We don't do that at all. Alright, so we're putting all these things down here. Alright, now for our cosine graph. This one's a little different than the sine. It just kind of moves everything over pi over 2. And again, we'll talk about that once we get to the trig part of our graph, our class. So the graph comes down, bam, comes back down again. It's kind of like a cycle. And the cycle continues to repeat itself. Okay. And again, we have arrows on both sides. Wow, they came out of nowhere. We have arrows on both sides. So negative infinity to positive infinity for domain from left to right. And then our range goes from bottom to top. It's the exact same thing. So they have the same domain, the same range. Alright, so those are all 11 functions right there. All 11 of them. Now, with that, if we go back and look and try to see which ones are power functions, we say anything, so just jumping back to the front again. Power functions, any function with a number exponent. So, anything with a number exponent. These don't have number exponents. These don't have number exponents. This has an x as an exponent here for the exponential, but that's not a power. That's not a number, so we can't use exponential there. There's nothing there, not there. Later on, we could talk about that. The square root could possibly be 1, but we'll talk about that later. Linear, if we look at that one, linear is actually understood as a 1 right there. So that could be a part of it. So we can say linear. All right, and then cubic could be 1 also. Cubic right there. That's 1. And then quadratic, if you look at that one too, that's another exponent right there, number exponent. So for our power functions here, these are functions like f of x equals x, f of x equals x cubed, and f of x equals x squared. So those are the power functions that we have in this foldable. So those are the only ones that you can do. So if I say, give me a power function, those are the only ones you can do. All right. So now it's transformations.